Neeraj sir, have you joined?
Manu, I have, but I'll have to quickly leave for another 15 minutes and I'll come back again. Is that okay? Manu, can you hear me?
Yeah, that is fine.
Yeah, boss, we'll manage.
I'll come back again and I'll join. I need just 15-20 minutes. I have some plant issue. I'll just join after that.
Yeah, not a problem.
Viraj, Hemant sir, you can give the go ahead whenever you want to start. Okay.
Yeah.
We can start.
Yeah. Good evening, everyone. Viraj, I think it's okay to start
Yeah,
the meeting.
go ahead.
Yeah. Firstly, thank you all for joining this knowledge sharing session today and taking the time out. We'll have a very brief session of about 1 hour and 15 minutes. We'll try to cover as many things as possible which would be useful for you. So the Indian Society of Structural Engineers, along with Tata Structura, in association with MPT Pipes, the business development partner for Tata Structura from Maharashtra, we are holding this knowledge sharing session today. I will not take any more time. I will hand it over to Neeraj sir, who will give you the context setting of the whole event. Neeraj sir, to you.
Yeah, good evening all, and I'm really happy to see such good audience. And in my prior role for TMT, I've already been associated with Indian Society of Structural Engineers. Mr. Hemant and Mr. Shantilal Jain have always been very cooperative with Tata Steel and now with Tata Structura and Pipes, along with MPD, to have such like knowledge sharing sessions, which we regularly organize for our engineering community. This helps us to bring out whatever new things Tata Steel is bringing in, what are the innovative things Tata Steel is doing, and what are the new capacity additions in Tata Steel, and at what areas and sections which the engineering community can work for. Those are the key areas which today I think this discussion will help us get an understanding on. From our side, I would like to just inform you that with the acquisition of Bhushan Steel, now which is renamed as Tata Steel BSL, we are one of the largest producers in tubes, both hollow section and circular. Our range has become huge from half-inchy pipes to we can go almost up to 24 inches pipe. And so many grades which are now being available from us from 3 plants where basically HR is our raw material from Angul, from Jamshedpur and from Kalinganagar. So that way we have become a very divergent group, and we now are well connected with all the AEC community, and with them we are trying to do a lot of development in the hollow section. So that's the area where we need support from all of you. And there are requirements of mega projects like metros, airports, high speed trains, wherein a lot of new kind of requirements, new kind of high strength material are being demanded. And those are the areas in which we seek your help. So not taking much of a time, the COVID times have taught us to be different, and organizing this program itself is one of those event where we are being able to connect to so many people. I can see almost 42 people already connected with us. So these are new times, and I believe this new option of getting into COVID times, and also being associated with people and still managing the whole show is something which is a great thing the nation has learned. In fact, for us, our efficiency level, if as organized and understood by the company, has gone very high. So COVID times have not taken us back. It has in fact pushed us to the future. And that is what I think is the understanding with which we should proceed in this whole program today. So Manu, thank you for allowing me to speak. I will rejoin in another 15-20 minutes. You can take it forward from here. Thank you.
Thank you, sir, for the context. I would request everyone to just mute their mics so that there is no echoes that are coming in. Now I would try to invite upon the Honorary Secretary of ISSE, Hemant Vadalkar sir, to just give a brief introduction for today's event and about ISSE as well. So over to you.
Good evening all. On behalf of Indian Society of Structural Engineers and Tata Steel, I welcome you all for this knowledge sharing session, which is very, very important. And I must say that Tata team has worked very hard for making this session possible, along with our ISSE team, our President Mr. Shantanu Jain, and other team members. Now, as you know, ISSE is an organization. Basically, we are just creating a knowledge sharing platform for the fraternity, for all the engineers who can share their knowledge through this platform. And ISSE is publishing quarterly technical journal also, wherein we implement all this know-how, latest construction practices, and the latest trends also in construction. So we are just conducting a lot of seminars, workshops. Now, due to this COVID situation, a lot of programs we are just conducting through the webinars, virtual meeting like this, for knowledge sharing purpose. So I appeal to all the viewers, to attendees, those who are not members of ISSE, please join us. Please join our hands, and then make the organization stronger so that we can just promote good engineering practices in the fraternity. Now I will request our President, Mr. Shantanu Jain, of course, to speak a few words, and later on I will come back and introduce the speaker, next speaker. We have very, very nice presentations today. There are 3 speakers we have talk on the steel tube structures. So Shantanu Jain, please.
Hello.
So we can hear you loud and clear.
Hello.
Yeah, go ahead, Shantanu.
Hello. Hello.
Yes, sir, we can hear you, sir.
Go ahead. Shantilal sir?
He has muted himself.
Hello. Now. Hello.
Yeah, it's fine, sir. Please go ahead.
Okay. Okay. Friends, I welcome you all for this event, which is connected with steel, especially tube structures, hollow sections. Today, this is organized by Tata Structura and ISSE. We have long association with each other. Professor Gadgil and Mr. Murli Krishna both are excellent in their this steel topic. We all know as an engineer, steel sections have its own advantage compared to other materials. And today we will gain lot of knowledge, especially when large span roofs, large span things are required to be done at a short period. Quickly we want to finish the job. Other materials may take lot of time compared to steel because it is a fabrication, erection. It can be done fast, can cover big spans, especially airport type of structures, big railway stations, big things which are very beautiful architecturally stadiums. So this property of steel tube and steel hollow sections play a big role. Is already playing big roles. We have seen it right from engineering when I was studying in VJTI. I was always saying why this hollow, why it is not solid. But when I came to know moment of inertia, section of modulus, then I thought, oh, this has great properties. And today, Professor Gadgil and Mr. Murli Krishna will give us detailed knowledge about hollow section tube structures. With this, I thank all and request everybody who is not member of ISSE to kindly join ISSE by visiting our website. Thank you.
Okay, I will now briefly introduce today's first speaker, Professor Manohar Gadgil. He is, of course, our professor. He taught us in college, VJTI, Structural Engineering Department. He is a retired professor from VJTI. But not only that, he is not only academician, he is also practicing consulting engineer. And he has designed various type of structures himself. Structure. I think airport hangars also he has designed long span hangars up to 100-meter spans. Not only he has designed. And with the brief introduction, I will not take much of his time, but we'll give more time to Professor Gadgil for his presentation, elaborate presentation. And he is just showing you the elaborate sea structures which he has designed. So over to Professor Gadgil, sir.
Manohar, sir, over to you.
Hello, can you hear me, sir?
Yes, yes, loud and clear. I would request everyone else to just please mute their mic.
Can I start now?
Yes, yes, sir, you can.
Hello, good evening, everybody. Nice to meet you on in the evening of this wonderful season. I am sure this Indian Society of Structural Engineers have thought of well of introducing a right topic at the right time, and with the participation from the manufacturer of steel itself, I think it is a great opportunity for all of us to get into the topic and see various problems associated with it, various opportunities with it, and so on and so forth. I think next slide. Can you go for next slide? My entire presentation, I will be covering these 6 topics. There will be general remarks with introduction. Then the types of sections used in steel construction, I will be discussing few items about that. Then types of structures with tubes as a member, which are ideally suited and many times used. I will be discussing that. Then the design of tubes in general, as far as the structural part is concerned, I will be discussing that. The most important point about the tube members is the connections. So I will be discussing that in brief, types of connections, and lastly there will be concluding remarks for that. Next slide. In the general remarks and introduction, I have considered these three subtopics. One will be general remarks, then there will be materials of construction, and advantages and disadvantages of steel construction in tubes. Now, when I studied structural engineering as an undergraduate student way back 50 years back, we can say, we had one subject of structural design. In that, one section was steel design, and second section was RCC design in the exam, and the third one was occasionally stress concrete. So I have seen many of my colleagues in the colleges used to keep the steel design in option altogether. Only the submission work was somehow managed, and later on for exam, very few people used to study that. So that was a time when people used to consider steel design as very difficult. Not only that, it had very limited applications because only industrial shades and things like that. There was application for structure. Otherwise, for most of the buildings, auditoriums, halls, and so on, nobody generally thought of using steel. And steel was always also considered as a common area for mechanical engineers and structural civil engineers. So many times, even the mechanical engineers used to do the steel design, and they used to get away with normal design, while civil engineers would generally restrict themselves to concrete. Now the things have changed, and mechanical engineers are almost driven out of the general steel design, and it is only primarily the job of structural engineers, civil background, who undertake generally the design work of whether it is concrete construction or steel construction. It is primarily the job of civil structural engineer. I think let us go for next slide. Yeah, under the general remark, we say that as far as the steel section, the tube sections are concerned, they are excellent members for resisting both the axial force and the moment. There are other types of sections also available, like the angles of the channels or tubes and so on. But we see that each section has its own problem. While as far as the tubes are concerned, as far as its original strength is concerned, it is excellent, very good, efficient section in carrying axial force as well as bending moment. Secondly, there is a chance that you can connect a member to another member, both of tubes only. Direct welding is possible for them. While for other types of section, like for example, if you want to connect an angle to another angle, it is very difficult to directly connect because the legs are there. Some legs might come in contact with the other section, but some legs might just remain free. So the connection becomes extremely difficult. Member to member connection is very difficult for other types of sections, while for tubes, it is an excellent option because you can directly get enough area of contact between the two tubes to be connected. Now, further, if you are using round tubes, then they have got very low drag coefficient. So the wind load gets reduced as far as the member exposed area is concerned. And if it is in water or current, the section like a column in the creek or river, then it has got excellent drag coefficient, very low drag coefficient. So the lateral force by wind or by water current gets reduced. So we see that it has got quite a few advantages over the conventional members, either the built-up members or the conventional hot rolled sections. Go to next. Now, for materials, there are various in steel itself. So we have got generally these 3 grades, but other higher grades are also available. YST 210 with a yield strength of 210 MPa and the ultimate strength of 310. If you go for YST 240, higher properties are available. YST 310, still higher properties are available. You have got further YST 350 or YST 460, higher grades of steels are available. So we see that as you go on going for higher and higher strength of materials, the capacity of member to carry load drastically increases, and that makes the structure lighter and lighter. I think go for next. Next. Okay. Now, basic advantage of tubular construction, if you see, that is say, using tube as a structural member, then we see that for such types of members, the self-weight is extremely low compared to any other section that you consider, whether it is an I section or whether it is a channel section, built-up sections, any other section you take, while this section has got a very large load carrying capacity for the same area, and the result of that is its self-weight gets considerably reduced compared to same structure made up of other types of sections. Secondly, it has got excellent torsional resistance. For many of the open wave section, like an I section or a channel section or an angle section, if you consider its torsional property, it is a very low torsional property. They are very weak torsionally. If you have got a structure where member develops torsional moment, then you have no option but to go for these closed tubes, either rectangular or square or circular. So we see that if there is any problem associated with torsion, then you have to consider this option, that use tubular sections for resisting the forces over there. Now, as far as the other types of forces are concerned, we see that most time the structural member that we have got, after carrying out analysis, we realize that the member might develop some axial force and some bending moment. If that bending moment is in one axis only, uniaxial moment, then we see that either an I section can be used or a channel section also can be used. But if it is subjected to biaxial bending, then for I section or channel section, their moment of inertia about other axis, the weaker axis, is very low. For I section also it is very low. The result of that is, if you have got a member carrying uniaxial moment, then you can think of some option that an I section or a channel can be used. But if you have got a member carrying biaxial moment, then ready-made sections like I or channel, they are not so efficient, and then you may have to either modify the section by adding plates and so on, or go for a tubular section, because tube has got excellent properties for bending in both the directions. The next point that we consider is it has got natural frequency. The natural frequency for these tubular sections is generally high. They are very stiff sections. Their stiffnesses are very large about both the axes. The result of that is you get structure which has got very high natural frequency. And when the natural frequency is high, then we see that for resisting many of the dynamic loads, the performance of such structures is extremely good. As far as another advantage of the tubular section is to be decided, then we see that many times the services like the drain pipes or the wires or the cables can be taken through these members. So there is externally an excellent architecture over here. Outside you don't see any of these services. They can be directly taken through the member. The result of that is aesthetically many times for some applications or for some, you can say, locations, it becomes very efficient and desirable to go for such types of sections, the tubular section. Another advantage of this tubular section is their surface area is low compared to the surface area of hot roll sections. The hot roll sections are exposed on their both the surfaces. I think we'll go for this. For hot roll sections, this for the same area, the surface area is larger, while tube type sections, they are exposed only on one face. The result of that is, if you want to do some anti-corrosive treatment or painting or fireproofing, then the area to be covered for tubular section is quite small compared to the area exposed by hot rolled section, area required to be covered for hot rolled sections and so on. So for other for other demands also, like fire resistance or corrosion resistance, you make the structure more efficient and more economical. The only disadvantage of this tubular section is that the manufacturing cost is high. Kg by kg, if you consider the cost per kg, then for tubular section it is quite high compared to hot roll sections or other types of sections. So that is the only point you have to remember, that you might save on the weight, but you have to see whether overall you are saving in cost or not, because the rates are high, the weight might reduce, but it may not compensate for rate variation, and in that case the overall cost may not be significantly reduced. So you have to keep a check on both the things, that is whether the weight is reduced substantially and whether the cost difference makes it efficient or more economical or not. Next. Next. Now, after having considered the general comments, now I am considering, I think, go for previous section, go for previous slides. Oh, okay. Now I am now considering the types of sections used in steel construction. With reinforced concrete, we have got a section which is to be made depending on the architectural requirements and so on. While for steel section, many options are available. You have got so many types of sections. So I always find junior designers always having first point or first query, that which section to be used, because he only knows that the axial force or bending moment is so and so. But shall I use a channel section, or shall I use an eye section, or should he use a tube section? So there is always a free choice. So many times the junior engineers or the newcomers are always in puzzle whether which section to use. So we have to check very carefully as to which section has got which plus points and so on and so forth. So we shall now see in this section the sections which are suitable for carrying axial force, those which are suitable for carrying uniaxial moment and axial force, those which can efficiently carry axial force and biaxial moment. Then we have got sections which can carry axial force, biaxial moment, and torsion. All of them, whether can a section is ideally suited for such demands or not. I think next. Okay. So now we see that the sections available are vast in number. There are various sizes available, various thicknesses available. So we have got an I section, we have got a channel section, the T section, the angle section, equal or unequal. Then we have got those sections with bulb type projections. We have got round tubes. We have got square or rectangular tubes, and we have got plain plates available directly for making any section out of that through welding and so on. Next slide. Okay. Now we have also got these built-up sections. That is, in addition to what you get in hot roll, you can add plates to it and see whether your demand is met or not. Then we have got cold form section, which are very thin sections. They are also used in many applications with their obvious advantages of lightweight and so on. So these various options are available. One has to judiciously select a section and see whether it meets the requirement or not. Go for next. Okay. Now, when you consider a member which is expected to carry only axial force, like in trusses and so on, then we see that angle sections are also an option. Either you can use single angle or a double angle, or you can use a channel section that is also enough, strong enough, or you can say efficient enough to carry axial force. We have got an I section or an H section, but it is very difficult to connect them in a truss. So generally I sections or H sections are not used, but if at all you can think of connections, then they can be used. Or round and rectangular tubes are also used for making the trusses. So if you have got members which are primarily carrying axial force, then all these options can be considered. Of course, each time you have to see what kind of connection you can think of and so on. As far as angle section is concerned, it has about 2 legs. The result of that is, if you are going to connect angle to a gusset plate with only one leg connected, then it becomes more inefficient, because with only one leg connected, its load carrying capacity gets reduced because of the eccentric connection that you are proposing. So each time, once you think of a connection, then it immediately puts a bar on the load carrying capacity of the members and so on. I think go for next. Okay, now if you consider a structure where members carry axial force and uniaxial moment, like a plane frame and so on, in that case, of course, you can use channel section, either single or double built-up sections, or you can use I sections because they have got excellent moment of inertia about one axis, or round and rectangular or square tubes. They can also be thought of because they are also very good in resisting axial force as well as bending moment. Go for next. If you have got a three-dimensional structure where the members are carrying axial force and biaxial moment, then of course you can go for I sections or H sections, which has got reasonably comparable properties about for bending about both axes, or round or rectangular square tubes. They are also ideally suited. So if at all you have got a structure where members develop axial force and biaxial movement, then you need to consider only two options, either an I or H section, or a round and rectangular tube, or built-up section in these shapes and so on. You can go for even channels built up, so that there are enough properties in both the directions, and then also these sections can be preferred. Go for next. Well, if you have a structure where the members develop axial force, biaxial moment, and torsion, then of course the only choice is go for either a round tube or a rectangular or square tube. Because when you are to deal with torsion, in these open sections like an eye or a channel or built-up sections, they are out of. I mean, angle is out of question because it doesn't have enough torsional strength at all. It is very feeble for torsional resistance and so on. Go for next. Okay. Now, when we consider with all these plus minus points and minus points, let us now consider when you have tubes, which are the applications where you can directly select tube as a primary member and think of completely planning the structure accordingly, and then suitable connectors for that. So the first type of structure that comes to my mind is a space frame with either 2-layer or 3-layer space frame with ball connectors or plate connectors or with special connectors. Then you have got space frame type structure. Primarily members are carrying only axial load, and in that case you can use definitely ball connectors or plate connectors. Then you have got large span trusses, where again you can consider using plates but with connectors which are of specially designed type or specially made connectors and so on. Go for previous one. Okay. Then you have got spherical domes or pyramidal structure or supporting structure for fabric roof, supporting structures for fabric roof. So for fabric roof also you need massive structural system on which the fabric is laid, and the structure supporting has to carry all the wind load effects coming from the fabric over there. Many of the stadia or the you can say many of the structures which are now seen at toll plazas and so on, there also you will see that fabric roof is is being provided in a large way, and there the supporting structure is many times made up of either the round tubes or square tubes or rectangular tubes. Go for next. Next. Now, this is one structure which we have recently designed. This is a massive structure. It is 40 meter in one dimension and 60 meter in the other direction. It is a single layer structure where special connectors, which I will show subsequently, are specially made. They are all made up of rectangular tubes, and the connections are provided in a special manner. I will show you that subsequently. Where this particular structure is extremely light structure with whatever the geometry that is possible over here and so on. So aesthetically very pleasing structure, and the connections are so delicate and strong enough that the structure looks beautiful with the presence of these connectors, which I will show you subsequently. Go for next. So here particularly we have used cylindrical connectors. Now with this toll plaza type structure where it is a double layer space frame, we generally use ball connectors because these members primarily carry axial force, and for axial force you need only a connector, a simple connector where a single bolt is used to transfer the forces from one member to the other through the joint and so on. We go for next. Next. Now this is a space frame again, but with plate connectors. Instead of going for ball connectors, because ball connector needs special secondary members or secondary hardware, you can say, and the balls have to be specially made with a lot of accuracy required for its corrections and so on and so forth. In place of that, the other option is go for plate connectors, which I will show you subsequently, where the tubes are crimped at the ends and the connection is made to a plate connector through the bolts. So the bolts in this case are in shear, while the earlier option that I have shown you where ball connectors were used, the bolts are either in tension or compression. I think go for next. Next. This is one dome structure of about 17-meter diameter that was designed, where again we have used ball connectors for its connections, and the dome has got a property that most of the members carry only axial force. The result of that is the ball connectors are ideally suited for connecting members to member at the joints, and such types of geometry can be easily conceived and implemented by properly drilling the holes to the node at specific angles, and accordingly connections are made. Next. This is again a pyramid type structure where tubes are used, but here instead of using ball connectors or plate connectors, direct welding was done for member to member, and accordingly the entire structure was made by only welding member to member connection. So all the members are tubes with required thickness and so on. Go for next. Is also a pyramid structure where again massive height was given for the pyramid. About 18-meter was the inclined length and the base dimension was 10-meter by 10-meter. So very steep slope was accorded, but the sections were used of all tube sections and they were all welded to each other. Go for next. Next. Now, this was one massive structure for the Commonwealth Games, which were held in Delhi, I think either in 2008 or 2009. So, this was an elliptical type fabric structure where the major axis was about 108 meters and the minor axis was about 60 meter, 53 meter, and so on. It was made up of round tubes. So we have used tubes of diameter 1 meter and almost 10 millimeter thickness. The columns and the ellipse were all made up of 1 meter diameter, while other members were made up of about 800 millimeter diameter. And they were all welded to each other. So we had to develop special connections, moment connections, where through these tubes or through these pipes, you can say, slots were made and plates were inserted into it so that full moment capacity of the section is mobilized. So developing the connections was a major challenge for it because the spans were massive, and not only the spans were massive, it required several splices through the length, and at the junction we had to properly connect the column as well as the ellipse in horizontal plane and the inclined member over there. So a geometry was very tricky, and connection at this point was totally developed through the plates which were inserted inside the pipes and so on. Go for next. Okay. Now, when you design the tubes, as far as the member design is concerned, for tube, the design is extremely simple because when you are what specific type of force, its load carrying capacity is well understood. So, when you are to consider a tube carrying axial force or a shear force, then you need to only consider the force that is developed either axial or shear upon the cross-sectional area which is resisting. And once you have the permissible stress depending on its L by R ratio, then the area required can easily be arrived at by trial and error and so on. So the design of tube for axial force is extremely difficult. It is just load upon permissible stress that directly gives you the required section and so on. As far as the bending moment is concerned, again on the same line, you have got a well-defined section with its section modulus also known. Accordingly, you can directly take the bending stress almost to the full capacity and then design the section for its applied moment and so on. While for torsional moment, this section has got excellent torsional resistance. So you have got simple torsional formula. The moment multiplied by the distance of the section from the center of rotation upon the torsional modulus, that is J. So that moment into distance from the center upon J, that gives you the shear stress, and that shear stress has got a permissible value from the material that you are using. Accordingly, designing it for torsion is also not a difficult task at all, because the torsional property, the polar moment of inertia or J as we say, now that is readily available, and directly you can consider the design in this simple fashion. Next. I think is my time getting up? Okay. Now, as far as the connections are concerned, we have got various types of connections available for connecting tube to tube. Out of that, solid or hollow ball connectors to connect members carrying primarily axial force, which I will show you in a minute. Then we have got cylindrical connectors carrying axial force and uniaxial moment. Now, those connectors also we have recently used for one of the projects. Then we have got plate connectors to connect members carrying axial force. So that also, that space frame time situation I will indicate to you. Then we have got directly welded connections from member to member. For tubes, it is possible you can directly weld one tube to the other, and there is no harm at all. Enough welding area is available. Or you have got the bolted and riveted connections to connect member carrying axial force and moment. It is similar to the cylindrical connector which I have shown. You can go for next. Okay, now this is one space frame that I want to show. It is a two-layer space frame with branches coming from the column. So there is a support from the bottom to the bottom grid, those four branches which are taken from the column. So these four branches are taken from the columns, and then at those locations they are connected to the ball connector. Next. Okay. Now this is a simple connection through for connecting members through a ball connector. So you can see that you have got these tubes, round tubes. They are connected through the bolt. Now for round tube, at the end, I will show you the details in subsequent slide. The ends are made solid by welding a solid rod inside it, of whose diameter is equal to the internal diameter of the tube. About 50 to 60 millimeter length of the solid cylinder is welded inside. A hole is drilled to it. There is threading in that, and a bolt is connected through the that drilled hole, finally going to the connector. So the connector can be a solid ball or it can be a hollow ball. If it is a solid ball, then you need some gap between the connector and the member, so that the bolt can be easily driven inside the node and the connection is made. Now this connection is ideally suited when you have got members carrying primarily axial force, because the bolt can carry only axial force in this particular case. Next. So we have got the bottom situation where we have got a bottom grid and the diagonals are going up. So you have got these connections made in the upper half of the ball connector, while the horizontal members are connected at the horizontal diameter of that solid node and so on. The connection is similar. Only thing is the angle changes as per the configuration or the geometry of the structure. Next. Similarly, you have got various other angles coming here. A T section is made where you have got three members in one plane, and then you have got diagonals connected. I think the connection arrangement is same. The angles at which you have to drill the hole, now that only changes as per the configuration. Next. I think this you can skip. It is going to the extreme end where you have got four members in a horizontal plane and four diagonals connecting it to the members in the other layer. Okay, go for next. I think go for next. Similar situation. Okay, next. This is what I have told you, that you can take a column from below, and then you have got four members in horizontal plane, four in diagonal, and a column below. So you can connect 9 or even 10 members in certain situations, and so there is no difficulty at all. Only thing is you need precision in drilling the hole and connecting it in a proper fashion. Next. Okay, I think this is similar to what you are. Go for next. Next. Now, when you are connecting it to a solid or hollow cylinder, a hollow node, that is spherical ball, then you have got a tube. At the end of the tube, a solid member is a solid cylinder or a solid rod is welded inside. So, if you have got a 60 mm diameter tube with outer diameter 60 and inner diameter say 52 mm, then you take a solid cylinder of 52 mm dia, put it inside about 50 to 60 millimeter, and then weld it on the surface, and then drill a hole through it, and then you connect it with the bolt. So you have got a bolt which is driven, which many times is put inside the tube at the beginning itself, and nuts are placed at this point, and later on when you want to connect it to the node, these nuts are rotated so that the bolt goes inside the node, and then you can connect it to a solid node. If you have got a hollow node, the situation is similar, except that in hollow node, the tightening is done from inside the node. So you can directly take the bolt, put it inside the node, and drive it and turn it inside the member itself. So you have got this solid portion which is called as prop. Now that is drilled with threading at its surface, and accordingly the bolt is engaged through the threads. So the axial force is directly transmitted through the threading arrangement. Next. This arrangement which I have shown you, which we have recently used for one of our project, where I have shown you that odd shaped structure, where the members were carrying axial load as well as uniaxial moment. The spherical node which I have shown you is ideally suited because it is only connected by one bolt. It can take only axial force. While in this arrangement, we require a member to be connected to the cylinder, but it had axial force and a bending moment also. So for that purpose, we have got this hollow cylinder. So this hollow cylinder of required length is taken, and then two holes are drilled. Two holes are drilled on its surface, and for this tube, for this rectangular tube, we have again got that prop, that solid section which is welded inside, and then it is threaded all along its length, while the bolts are driven on from the inside. That is, bolts are put inside the connector, and then they are so that they get engaged to the member at its prop. So you have got two bolts connected. So those two bolts take axial force also, and because it is subjected to moment, one bolt develops tension, other bolt develops compression. So with the couple formed by the forces in the member, by the forces in the bolt, it is able to resist the bending moment also. So with the arrangement of two bolts in one plane, one vertical plane, it is able to take axial force, which is same in both the bolts, while due to bending moment, in one of the member, axial force gets reduced, and in other member, it gets increased because that compression gets increased. So if axial force is tensile, okay, the tensile force will increase and axial in one bolt, while tensile force will decrease in the other bolt, and so on. So this is the way the solid cylinder, the hollow cylinders are used to connect the members which carry axial load as well as uniaxial moment. I think go for next. Now this is a kind of plate connector that I'm just showing you. It is a typical plate connector where a horizontal plate is considered and then two vertical plates. In this case, of course, double plates are considered, and then the connections are made for connecting in all 8 members to this plate connector. I think go for next. There I will show you the photograph of this plate connector. Go for next. Okay, now this is a typical space frame which we have recently, I mean, 1 year back, we have recently completed in Thane. So in this case, it is about 30 meter by 30 meter space frame with depth of about 2 meter, and it is it is made out of round tubes, while round tubes are flattened at the ends for required distance so that two bolts can be connected to it. So we have got this plate connector which is having a plate in one plane, and then there are two additional plates welded to it, forming a plate connector so that four diagonals can be connected to it and four horizontal members can be connected to it. I think, can you go to next slide? I will show you the further connection. Okay. Now here you can see that you have got a round plate, and then two half round plates are welded to it, one going this way and the other going that way. So the other plate is made in two parts, one up to here and the other one going from the other end. So that now you have got four diagonals members connected to these semi-round plates, and for these full round plate, four horizontal members can be connected. It is connected by two bolts. Those bolts are in generally single shear, and accordingly the diameter of the bolt can be decided depending upon the force in the member and so on. So this is ideally suited for members carrying axial force itself. For bending moment, it is not much of use. And if it is a secondary bending moment, very small value, then it can take care of that. But if it is primarily axial force, then this is ideally suited. You don't need precise geometry like the ball connector, where ball connector needs precision. The drill is to be done in a specific angle, and accordingly, very precise threading is to be done on that, and so on. Well, this is relatively a very simple technology. Next. This is again a bottom connection where diagonals are going up while four horizontal members are connected to that horizontal plate over there. So this is a typical bottom connection, bottom node connection with four diagonals going up and four horizontal members in single plane. Yes. Next. Okay. Now this is a case where we are able to use the welding of member directly to each other. So if the member forces are not very high, and if the plate of the connected member is sufficiently strong, that is thickness should be reasonably big, that is maybe 8, 10 or even more, then it is possible to connect these members directly to the other members. Only thing is, in such cases, you have to take precaution that local bending does not occur. So, if your section has got very thin plate, then this kind of welding is very difficult. It can lead to local failure. When you have got round tube, then you have to have a precise cutting of the member, because the member should be perfectly in contact with the other member. So profile cutting is required, and with profile cutting you can again weld to member to member, but these should be secondary members with reasonably small force. Then only such kind of connections are made. If the forces are large, then you need to strengthen the parent member by providing additional plates of whatever thickness, and then directly do the welding. So you need to weld on this member itself another plate which is again round, and to that plate now you weld these members and so on. So that is, I think, as far as the connection between member to member in a direct fashion is concerned. Now this saves a lot in the weight of the cassette plates and so on. So such structures become reasonably light. Next. I think we are almost coming to the end of the presentation. I think I have exceeded my time limit. I think with these types of connection, you can always go for modular construction. Different parts can be assembled at ground and then taken up and then connected directly. As far as the tubes are concerned, you generally get a high strength to weight ratio for the material itself. The strength is large.
Gadgil sir, can you just unmute yourself and just start the slide again?
Yeah, I think thank you very much. Thank you very much.
No, sir, you can conclude. I had to unmute everybody because there was slight disturbance. So you can just finish your last slides.
Okay, I think now go for last slide only. I think last slide. Next. Okay, thank you very much to ISSE and as well as these Tatas who have given me this excellent opportunity to present my work over here and talk about some of the basic concepts involved in selecting the sections. And in steel construction, the main problem is always the connection. So you have to always think of the connections as to how you can connect different members and then only go for proper choice of the members and so on and so on. I think thank you very much. Thank you, sir.
Uh, yeah. Manohar sir, thank you so much. Though, I mean, there was no problem with exceeding the time. I'm sure this is something that everybody actually wanted to see and understand. You could actually see it from the number of questions that were coming on the side also. I mean, as long as, yes, there's a lot of knowledge being shared, I don't think there's any problem with the time being spent also. So thank you so much, sir, once again, for being a part of this session. Now that we are already...
Being a professor, I always wait for the bell to ring to conclude my lecture, and that bell was not ringing, so I continue. Sorry.
So we didn't want the bell to ring because there were too many interesting things that you were talking about. So thank you so much, sir, again. Yeah, so now that we are slightly short on time, but then I'll just quickly take you through Tata Structura YC 355 sections from Tata Steel. Most of you would have already been using this. In fact, it is from the architects, engineers, and designer community that we actually learn what is it that we have to really bring out. It is actually your feedback, your creativity, and the things that you want to explore as a designer or as an engineer that actually makes us come out with these products. And we are requesting and we know that we will have your continued support for the future as well. So I'll not take too much of time here. Yeah, so Tata Steel, as you know, is today probably one of the largest steel companies, not just in India, but also in the world, more than 30 million tons of capacity. You would have been seeing it in the papers that in the last 2 years, we had made an acquisition of Bhushan Steel, whereby we had actually increased our capacity by another 6 million tons. Today, we are the third largest tuber in India with a market share of 9%, and we have a manufacturing capability of close to 1.3 million tons per annum. And our four lines of business are conveyance tubes, which you generally see are used for firefighting, HVAC, industrial applications, structural tubes, which you are dealing with almost on a daily basis in and out. Precision tubes, which generally go to the automotive segment. And now with Bhushan Steel, we also have can supply API grade, wherein which we supply up to X70, which actually gives you an heat strength of 590. And but this is primarily used in the oil and gas industries. But today we have that capability to produce sections which are that strong as well. You must be aware that there are a lot of new investments that the government of India has announced, especially with airports. Initially, Santilal sir was mentioning about the various schemes. Even Neeraj sir was actually telling about it. There are about 100 new airports that government of India is planning to do, which includes modernization of the existing ones also. Railways, very much in Bombay itself, the various stations like Bandra, CST, all these are going to be redeveloped. Today, if you look at a station like Habibganj in Bhopal, it is so the way they've designed it. Ecom. I'm not sure if they're with us here today, but how well the design has come out. It looks absolutely like a world-class structure, and nobody would ever call it a railway station anymore. They'd rather call it an airport, or it almost looks like that. The Pradhan Mantri Awas Yojana Gramin scheme, wherein there's a lot of focus that is coming on the water pipeline segment also. And refineries is also another segment that we see. I think there are members today from Toyo that are attending this meeting who have been very much involved, in addition to other of our very good customers like Tata Projects and so forth, who've been in refineries. And we see that there's a lot of expansion coming here as well. YST 355 high strength hollow sections. So Gadgil sir had mentioned the 310, and he had also spoken about 355 and 450. But this is something that we've launched, and we've also come out with. We can also supply grades in E410 if required. Various segments that we generally cater to are industrial, infrastructure, housing, commercial, and general engineering. Gadgil sir was mentioning about how important torsion, how good hollow sections are with respect to torsion. General engineering has started to realize that generally where they were using channels and I sections, now they've actually started hollow sections. So I'm talking about segments which are apart or which have traditionally not used this, but now are witnessing things that are happening in the construction industry, and because of the material ability, they are actually trying to implement it for their requirements as well. So the typical. I just want to point out the charka, which probably most of you would have passed by. This was actually designed by. They had actually used our tubes for it. A similar structure now has been built in Bhubaneswar, and a new one, a diamond structure in Jamshedpur, which I would really request all of you to take a look at. It's amazing that what architects and designers can actually do, their creativity, how much they can aspire, and how much they can use this material or tubes as a product. In YSC 355, just like what Gadgil sir was mentioning earlier, you would have seen that in TMT things where the standard was FE415, we moved to FE500D, then we moved to FE600. Obviously, the idea is we give you a higher strength material, your overall steel consumption comes down, and thereby your overall costs also. And that is the same ideology with which we are also coming up with. We've come up with 355, and like I told you, we can produce 410 also, and even a 490 if required. Neeraj sir had initially mentioned with the acquisition of Boost, so at one point of time we were restricted in our capability up to 10 thickness, but today you might be, I mean, you would know that we can actually supply sections, circular sections in 610 OD up to 20 I believe there are members from Stoop here who've done an amazing Sabarmati flyover where they've used really huge circular sections. These are probably had to be made through different sorts of equipment earlier using plates, but now these are sections that are actually available ready-made. Thereby, you can actually use this for your various requirements. Similarly, in square hollow sections, we've come out with 400 into 400 into 16 in rectangular, we can do up to 400 into 200 into 16 So these are like the sections that we've now come out with and which are readily available for your consumption. A lot of talk has been generated on sustainability, on carbon emissions. How is it that we can get a better green building certificate for ourselves or for an LEED certification? So at one point of time, it only used to be we'd get a requirement saying what is your recyclable content, what is the logistics, how much is the distance that you've had to travel for your raw material up to your production. So these were the typical questions that were asked. But today I'd like to tell you that Tata Structure is one brand which is Green Pro certified. This actually helps with your green building certification requirements. Yes, it compared to a product which does not have a Green Pro certification, we obviously stand at an advantage. And this is because of the various initiatives at the back end from our manufacturing process where we've done and where we've seen that we reduce carbon emissions. And sustainability, sustainable construction is something today that we are very much looking forward to as well. Okay, so today with the current scenario, you must be seeing that a lot of requirements are coming in from North America, from Europe, a lot of requirements from various others. So, and there are applications like what I'm showing you over here, tower cranes or monopole towers, or even for refineries or fencing, where in which they require grades which are as per European specifications. Let me tell you that our mill today in Bhushan has a capability, and why they want it in European specification, one major reason that they say is because the temperature gradient that happens. There are materials which would have to withstand temperatures of 0 degrees or probably at minus 20 degrees Celsius. Today, we have a mill where we can produce sections which are up to minus 40, which are capable to withstand temperatures of up to minus 40 degrees Celsius. In addition to sections that are available as per European specifications, we also have ASTM sizes. Typically, you would have been restricted to use sections like 150, 150 or probably 180, 180. But now we have roll sets like 175, 175, 140, 140, which are typically used abroad or which are typically used for applications that you've not seen of. But let's say a section like 110 into 50 or 150 into 110. A lot of airports have actually started using this for their facade requirement. So this is one of the new grades that we can now supply for your requirement. Similarly, Gadgil sir had mentioned about connection. So we've seen that a lot of times people do not want to get into hollow sections because of the difficulty. It was the one red line that he had marked in his second slide, probably because of cost and because of connections. Now, in connections also, a lot of people say square and rectangular are fine, but in circular, it's very hard to get the profile cut right. So this is something, this is again a facility that we tied up with an external vendor, Shekpur itself, wherein which if required, upon requirement, we can do it. We can convert the 3D model into shop floor drawings directly. Thereby, it gives you an accuracy of up to 5 mm, wherein which you are able to connect it to your plates properly. You're actually not dependent on any manual labor, and your project gets executed at a much faster pace. Like I mentioned, 400 into 400, 400 into 200. This is something, and 610 OD. 610 OD is something that people have now started looking at using for their hoarding requirements. You'd see these large signboards where people are actually looking at using those. You would have probably gone to Hyderabad airport and seen those columns where they were huge, gigantic columns, but those had to be imported at one point. But today we give you the flexibility of offering you 400 sections up to 16 mm. Like iconic projects like the ISSE Dwarka, one of the biggest exhibition centers in the country. They've used more than 300 tons of 400 to 200. In our itself, that the upcoming railway stations, the way they've used their cover over platforms with sections like 400 OD and 500 OD, it is just amazing that the various things that can be achieved by using these circular sections, because you're not dependent on fabricating any plates anymore. It is more about the aesthetic prowess that you get because of using these sections. Again, there is no manual labor involved. There is no plate fabrication involved. So much cleaner and much more aesthetic than what is actually what you generally get if you're doing it manually. This is one area that we would request all of you to explore. Again, steel inherently is not the best for fire resistance. Bringing concrete in can actually help mitigate that issue. The advantages of putting both concrete and steel together, it can actually reduce the construction time by a much faster rate. Your steel consumption actually reduces. You see that floor space area for apartments today is a very big problem. that floor space area, you go for you go to buy an apartment, they tell you a particular square feet area, but you end up getting something else. Today, you're able to design these columns at a much smaller, I mean, you can design much smaller columns, thereby that livable floor area or that usable floor area. The overall cost saving is also up to the tune of around 10 to 20 that you can actually achieve by using concrete. So that was just a small brief from my side. Now I would like to, though Gadgil sir has covered a very big portion in connections, I would still want Murli sir also to take us through his portion regarding connection details. So I'll just invite Murli sir, who is the who used to be the head of business development for Tata Structure, and now he's moved into the new material business. Again, looking at extremely new products, extremely new innovative things like what people are looking at, like FRP and glass reinforced concrete and the likes of those. So, Murli sir, if you can start with yours.
Thank you, Manu. Good evening, everyone. Just myself, Murali Krishna. Till last month, I was part of this Structura team. Actually, I started my career in with Structura. I'm a basically a structural engineer who has spent 10 15 years in design and market development with tubular hollow sections. That's why what Gadgil sir was telling about hollow sections. As he rightly said, in college days, our steel design itself is very minuscule, and in practice also, 80% design is up. Only 20% that is steel design is majorly for industrial buildings, mostly, or some marriage halls where the spans are very high. That's where some truss designs happens to be steel design, either angle back to back or star angle or thin side of the facade or both sides of the facade. All these what we have done over the years. But when it comes to hollow section as a structural members, why it has happened? Just I will give a small story. If you see these tubes or pipes, basically meant for conveyance of something, either water or air or gas. But some material came and it has replaced steel tube. Why I'm giving this example is if that is suitable for that particular application, it will happen today or tomorrow. It is going to happen. That's why if we see our old buildings, all plumbing pipes are all irrigation or borewell pipes or conveyance pipes are steel. But now that is UPVC or CPVC, which is a better material for that application. That way it has not. But however, in the country or in the whole world, if you see, steel tube production has increased exceptionally very high, exponentially very high. The reason these sections are more economical than conventional structural sections. That's why the replacement of conventional structural sections like angle panels have been replaced with tubular hollow sections. Why? There are two reasons. One is aesthetics, and the second is higher strength to weight ratio. Higher strength to weight ratio, how? What Gadgil sir has shown, 3 is having a very high torsional resistance and high moment of inertia or radius of gyration. For these axial members, any truss kind of frame members, the members are subjected to either axial compression or tension. The radius of gyration and yield stress are the main two guiding criteria which will decide the sectional cross-sectional requirements. And as technology improves, our high-strength materials are available for producing these tubes. If, for example, if I want an angle in 350 grade or 450 grade for angle section or a C section, it is very difficult to get. But in tubular, it is easier. The reason, the raw material required for producing these tubular sections are hot rolled coils. Hot rolled coils are also used for so many other applications. like your automotive, which uses very high strength steels, or other equipment or mechanical kind of applications, like your white goods or your machinery, like yellow goods. All these use a lot of HR plates which can have a higher strength of steel coil, HR coils. Those coils are the raw materials for producing these tools. That's where the higher grade structural sections, it is much easier to get in hollow sections. That is the reason, because of their higher sectional properties, because of hollow sections, it is having higher radius of gyration, and second is higher yield strength. It is being replaced the angle channels for the truss members. To keep it simple, you compare any airports. All airports are made of hollow sections because there is very large terminal buildings, column free spaces are required. That's where the span of the trusses are very high, and the aesthetics are more important. More people will interact with those structures. That's where the aesthetics also. If you are putting an angle truss or a I section column, people will not accept. If you are putting a circular column or a rectangular or square column, people even doesn't understand whether it is a RCC or XP. That kind of look you can take with your these hollow sections. But the problem is how to connect. There is a lot of knowledge gap available. For a decade, Tata Structural team has tried to dissipate this knowledge from what is happening internationally, and we are bringing a lot of literature as well as practices, good practices available in this Tata Steel. And we are sharing with our age group. In that regard, still we are facing three problems in hollow sections. One is
Only can you slightly adjust your mic? Slight.
Mike. No, I'm not having any.
Okay, go ahead, sir. Go ahead. No problem.
Yeah, I'm in front of laptop. That's why. Okay. Let me earphones. I will adjust. Let me try it. Is it okay now? Hello, Manu.
Yeah, it's fine. It's fine. Absolutely.
Yeah.
You speak in your normal voice. You are speaking low. That is why we can't hear you.
Okay. Thank you. No, thank you, Niril. No. Um, there are three problems in hollow section. One is profile cutting of circular section or even square and rectangle, and second is how to design a connection. Being a civil engineer or a structural engineer, we know if a two angles are back to back of an gusset plate, I know what is the length to be that weld length. Weld will be checked for the shear, and what is the length of the weld required along the gusset, I know, and I can design. When the member to member in hollow section, if you are directly connecting, that failure type is different from an angle truss. In angle truss, what is happening? The member is not failing because of the joint. The member is failing because of your member force. Whereas the gusset is extended along the member to accommodate the weld length required for that member force. Whereas here we are not providing any plates for the member to member connection. And hence the typical failure or design philosophy for the tubular connection is different. What Professor Sir was telling, for that wall connections, it's okay if it is a solid or a cast steel or a hollow ball. Then the philosophy is again the shear strength of that wall or the thread length, that is you will calculate and you will do that. But when it comes to square or rectangular section or circular section, direct member to member, you are connecting in a truss, then the behavior is entirely different. Now I will try to put up some of these issues and what you have to consider. I will discuss. What is the important is, whenever you are pursuing a truss type of design with hollow section, always from the beginning itself you thought of the joint capacity, not only the member capacity. For example, I am having a top card, bottom card, and braces. In this one, if you know it is a 25-meter span and it has to be taken this much load, then on the truss for that loads, you finalize the top card, bottom card, and bracing members. While selecting those members, whether the joint for your configuration of the truss member, you have to consider the joint capacity also. Otherwise, your member may be safe, it may fail in the joint capacity, as you are not going to put up any reinforcement plates. If you are ready to put up that reinforcement plate, one of the last slides Professor Sir has shown, on face or bottom of that circular plate you can put it, that is, it will become more difficult. Instead of that one, some of these guidelines if you follow, that failure may not happen, will not happen. What are those? Always you remember, around 50% of the your steel goes into the compression cord, another 30% goes into the tension cord. The truss is nothing but top card is top card and bottom card and braces. Bottom card is truss member. If it is a simply supported truss, then bottom card is your tensile cord and the top card is compression cord. And these are the shear force. Nothing but it will transfer. The bracing members is only 20%. A tension cord is only 30%. And compression cord is 50%. That's where for any truss, compression cord will is the major volume. There 50%, the axial compression resistance is very high for the hollow sections. That is the main advantage. And now in this 50%, while you are selecting a section for the compression cord, always you remember it should be minimum diameter or and higher thickness. For example, for compression, the cord member requires 180 6 mm or 150 8 mm. You should go for 150 8 mm, not 150 180 6 mm. Instead of that one, this will give you a better joint strength. And similarly for bracing members, you should go higher diameter and thinner. What will happen? For example, for my bracing members, 50 4 mm is enough, or 80 3.2 is enough, or 60 3.2. 60 3.2 you go. Then what will happen? Your cord is lower diameter and thicker, and your bracing member, when it comes to connect to the cord, there the bracing member wall and cord member wall will come into the same line. The secondary failures of the joints will not happen. That is one understanding you keep in mind. Now we will come back to what are the types of joints and what are the failure modes. Then you will understand why I was telling that one. Manu, these are the basic type of joint connections, either X or T or G, N type or Manu. Next slide, please. Yeah. Now, if you see this nodal eccentricity, you should concentrate on that. While doing the structural analysis, what is our major assumption is all the members will, all the CG lines will join in the same point, so that there will not be secondary movement or eccentricity in the joint. For example, if you take eccentricity to the ratio of your height H0 or D0, okay, is within these two, then the secondary failures will not happen. And what are the type of joints? Gap joint. If you are having a gap joint, it is easier for the fabrication, but it will create your secondary movements in the joint, and secondary failures will happen to needs to be checked. And how much gap you can allow maximum, always remember that is the gap should be minimum of T1 plus T2. If there are two bracing members are coming and joining and you want to provide a gap between these two, at least T1 plus T2 should be the minimum gap. That is for accommodating both the welds of this bracing member. if the weld thickness is never should be less than the thickness of the bracing members. That's where if you are having a left bracing T1 and right bracing T2, T1 plus T2 should be the minimum gap between the gap joints. If you are having a gap, then eccentricity will be negative or positive or fully overlap or partially overlap. Overlap joints are much stronger, but fabrication is different. And partially overlap joints also very comparatively gap joints much stronger, but you will have to fabricate the ends. You have to profile cut the ends to that partial overlap joint configuration. These are some of these guidelines. Manu, next slide. This is what I have discussed. Partially overlapped gap joints and fully overlapped gap joints. Next, failure modes. Next slide. This also I have discussed. Next slide you show. Yes, yeah. These are the failure modes. If you see here, either both are almost the same. One is for left side is your circular hollow section and the right side is SHS and RHS. Where the failures can happen? Weld failure or laminar failure or cord local buckling. Cord local buckling, if you see, if the your cord face is not sufficient enough. Initially, I have told you select thicker and smaller for the cords. If you are not following that, then this type of failure will happen in the cord local buckling. Your bracing member is much stronger, but however, your cord face is not sufficient to take that bracing member load. That's why cord failure will happen, or cord shear failure may happen, or cord punching shear may happen. These are the cord failures or cord plastification can happen. To avoid that one, what you need to do, you have to quantify. For example, what I was telling, cord should be smaller and thicker. How much? What should be the ratio of? There are guidelines provided, like if my bottom cord dimensions are B0 is the width, D0 is the depth, and T0 is the thickness. And bracing member is B1, T1, D1. Then B0 to B1, B0 divided by B1, B1 by B0 should be not more than 0.85. And the T0 to T1 should not be more than this. These guidelines, if you follow, then that failure will not happen. If you are selecting overall optimizing and selecting the members, and this criteria is not falling in that given criteria, then you have to provide a reinforcement plates, what Professor Sir was showing in the last slide. Then if the failure is happening in the your cord plastification, then you have to put a horizontal plate and that, and then you bring your braces. And where you will get all this data is there is a select guide available for all these connections. What should be this B0 by T1, T0 by T1, what should be the, for what type of connections, for gap joint, what should be that, and for overlap joints, what, all these guidelines given in the get guides. And from that one, we have prepared a one booklet in booklet form. Those solid examples also we can share with you as a wherever you can use that one. Next, Manu. Yeah, just to general understanding. Before that is the guideline what you can do, but however you as a theoretically you should understand what is the load path for how the connection behaves. Whenever you are connecting with a plate, for example, your one truss is there, the next truss is at 6 meter, another truss is there. Now if you want to connect with a at bottom cord, you want to put a strut For that one, you will put a plate perpendicular to the bottom card on both sides, and another hollow section you will bring and you will bolt it or you connect it. Now, bottom card of the truss is having a perpendicular plate. That's what I'm drawing here. Now, for that one, how the load path will happen? First, the load will pass through the plate, and then plate is connected to the face of the bottom card. That's where it will, your weld should be sufficient enough to transfer that load from plate to the face of the hollow section, and then your hollow section should be sufficient enough to transfer that face to the perpendicular face. Then the entire section will be loaded. That's where, while designing the connection, you have to think of from where the actual load is coming and what type of plate or directly I am through which weld I am connecting to that. That's why from that member to weld to the connecting member, that should be the load path. Next, Manu. Yeah, this is what I would like to tell. And also from Tata Structura team, what we are going to give you is this concrete fillet tubes. We have done since last 1-2 years a lot of research on how to economize steel as a construction material competitively in housing and commercial. Steel is always used for your industrial applications, warehouses or any building, any factory generally. But when it comes to industrial housing and commercial, still we are very much use RC. But to bring the advantage of steel and faster construction, what Manu has just touched up, there is a lot of potential as a team. If we work together, you are having very big hollow sections like 400, 400, for example, 500, 500. If you fill with that one with a concrete, that column can take you much, much higher load than a simple arithmetic sum of concrete load and steel load because of your confinement action. What will happen when you fill with a concrete steel tube with concrete? Then, if you are applying a load, the load will go to the steel first, and the steel column will try to buckle, and then it will come in contact with the concrete, and the concrete will start taking the load.
Only sir,
And
just
concrete,
1 second. I'll just mute everybody because there's a disturbance. Yeah, sir, go ahead.
yeah. Uh, uh, I was telling about the concrete fillet tubes. That is, there is a lot of potential you can do for this concrete fillet tube. Some of you may have some doubts. Sir, why now? Why can't earlier we have not done? Earlier, the available sections of hollow sections in the country are very minuscule. Like 250, 250 was the maximum size, and that also 10 mm. And with that one, you may be building maximum 2-3 store buildings, not more than that. Now we can give you 500, 520. And what grade of steel? Up to 450 we can give. And if you fill with a concrete fillet tube with 500, 526 plate with M50 or M40 grade concrete, you will get up to at least 10, 12 story buildings within time. And with that one, what you will get the advantage, the column sizes will come drastically less, very minimum. And at the same time, your construction time will save drastically. In the RCC column, you have to put shuttering, and after 7 days, you have to remove and reinforcement and everything, dewatering, watering, all these nonsense activity at the site will be removed completely. You can skip. And when it comes to technology wise, yes, we are also understanding whether how it behaves. If I am putting a, basically all these doubts should come into as a civil engineer. In PMP, in reinforcement bar, we are having the grid. That's why bond strength will be there. But here, tube is having a plane surface inside. What is the bond strength? What is the bonding between concrete and steel? If there is no bonding, then how it behaves? These are the doubts. But I will tell you, we have done enough testing and literature study and enough examples are there to uh, explain that there is not required of any bonding between concrete and steel in a concrete fluid tube. The behavior is different. How this behavior will happen? If you imagine, if you are having a column of a circular tube or square tube and you fill it with concrete and a compression load has applied, then what will happen? The load first goes to the steel and steel will start taking that load and tries to buckle first. And then that buckling will be arrested by the concrete core. When it come in contact, there will be a small gap in microns. Then what will happen? The concrete will start obstructing that buckling and it will start transferring, the load will transfer from steel to concrete. And once the concrete starts taking the load, it is a simple PCC, plain cement concrete. It will try to come out. But steel is having a hook truss kind of thing will develop. It will not allow the concrete to come out. That is the reason why the individual arithmetic sum of the capacity of concrete and capacity of steel, the concrete fluid tube is much higher than that arithmetic sum. Due to this confinement action of the tube for the concrete strength will reach to its ultimate, whereas because of concrete and steel work together, the composite action will come. And the other advantage is it will give a much better ductility required for the. And third one is it will enhance your fire resistance capacity. Fire resistance capacity means I'm not telling a simple RCC. It will be better than your simple hollow section. If you are putting a hollow section column, the fire capacity is X, and if you fill it with concrete, it will be X plus some delta X. There is a much improvement in fire resistance capacity of a hollow section. If you are comparing with RCC, yes, definitely still at par, not better than RCC. But with plain hollow section, fire resistance will increase. That's why these are some of the works Tata Structura team has worked out. If anybody is interested from your association, our team will be ready to work with or collaborate with you or do some working. This is what all I want to tell. And another, I don't know, Tata Steel has entered advanced materials, non-steel materials, composites and graphene rich graphene materials. These also will come to you again wherever you are facing some problems for corrosion and some applications wherever it is required, light weighting is required. There we are into fiber reinforced polymers or carbon reinforced polymers. All these Tata Steel just entered. Just for your information only, I'm telling. That's where from construction segment, whatever be the material, along with the steel, other advanced materials also we are trying to rope in and provide the service. Thank you. Yeah, Manu, back to you.
Thank you so much, Murli boss, for taking this time out and uh, giving us a brief on connections and concrete filled tubes. Now I think we are all done with all the presentations, but I see that a lot of questions have come in, especially from Arunanju sir, who was with Atkins earlier. Uh, we can actually have a round of question and answers. If you have a particular question to take, you could just unmute
Yeah,
yourself and give a
yeah.
question. I think Gadgil sir is still there with us.
Manu,
Yeah,
what I suggest, whatever the questions in chat box, we will
yeah,
reply to them. Okay. But however,
that's
any
also fine.
participant want to ask any direct questions, we can answer that one, and then you can respond to them. If there are so many questions, then you can respond to. Otherwise, which one to select? It's not
Totally
there.
fine. Totally.
Yeah.
You can choose the questions, and I think some few questions you can take up so that the experts can guide on that.
Okay, so I'll just go with the questions one by one. Can we? Olavo sir has asked for a video and a presentation, so we are having this entire session recorded, so we can send you the link, and you can always use it whenever you want to. Sachin Patel sir has asked, what is the cost difference ratio between hollow section and solid section? We could send a comparison for this. That's not a problem. Same with RCC structure and MS structure. We have.
Manu,
Yeah.
generally 1 minute. That cost comparison. Sir, always the steel prices fluctuates, and it may generally tube prices or hollow section prices decided by HR coil price, whereas conventional sections angle channel prices will be decided by the billet prices. That is one. And generally, I'm the ballpark figure. I'm telling always hollow sections are at least 10% to 15% higher cost. However, your steel consumption will reduce minimum 30% to 40%. That's why if you are paying 10 to 15% higher cost for the hollow sections also, you will have a overall saving of 10 to 15% in your fabrication erection and everything complete job. That's why hollow sections always plays an important role in your cost economics for framed structures.
Carvalho sir has asked for, I think Gadgil sir, this is for you. He wants a reference for design of ball connections. Gadgil sir, if you're there, if you could just respond. Or Murli sir, anyone would be fine.
Huh? Pardon? Oh, I have not gone through. What is the question?
Reference for design of ball connections.
No. I don't know. Yeah, I really that is that space frame guys only can tell. Theoretically, we know that one, but how to design and everything, we have never supplied or we don't have any idea of that. Ball, it is a cast steel. That's why it is a certainly
Gadgil sir,
different.
your expertise would be slightly required for this if you're still there in the meeting.
Manu, we can pick up some questions randomly from the chat below. If you could.
Yeah, I'm picking those only, Viraj. Those
Yeah.
questions I'm taking, yeah. Manohar sir? Okay. Carvalho sir, there is a SIDEC guide, but anyways, we've noted this question is there. We'll just respond to you in the next couple of days. Please provide reference for these hollow node, solid node, and rod which we weld inside the branches. Again, this is Vadalkar sir, is Gadgil sir still there in the meeting?
I think he's there, but muted. I saw.
He's on mute.
Because he has designed a lot of, I think, ball joint structures as well. So he knows about it. And I think, see, many people are asking about the connection design, the reference for that.
Yes.
So within Tata Steel, you will also have some kind of booklet. You can request Gadgil sir also. Gadgil sir. Yeah, he is there now.
अभी उनके पास वो डायनेमिक्स का डेटा ही नहीं है, वो आरपीओ है ही नहीं बोलता है। अभी दुनिया में कोई मशीन होता है जो वो होता है पार्ट्स और बोलते हैं आरपीओ है ही नहीं।
आपका वॉइस थोड़ा कम आ रहा है, थोड़ा
सिमुलेशन फ्रीक्वेंसी चाहिए ना, कितना
हाँ
साइकिल पर मिनट होता है, उसके साथ वो रेजोनेंस आता है कि नहीं देखना पड़ेगा। तो ये मशीन में अंदर उनका ड्राइवर होता है, तो ड्राइवर रोटेट होता है, उसके बाद वो लोग गियर सब लगा के सर्कुलर मोशन इज कन्वर्टेड इन लीनियर मोशन, ऐसा होता है। तो अंदर उनका जो रोटेटिंग पार्ट तो रहता ही है ना, ऐसा मशीन एकदम आगे पीछे कैसा नहीं है, वो पहले तो उसको मोशन देना पड़ता है। हाँ वो हाँ नंबर ऑफ साइकिल्स पर कितना होता है, वो इधर से उधर उनका गार्ड घूमता है बराबर, पर अंदर जो ड्राइवर रहता है वो मोटर है ना उसका, वो मोटर सब ड्राइव करता है पूरा 10-15 पार्ट जो अलग अलग घूमता है, वो मोटर की वजह से घूमता है। तो वो मोटर का बेसिक हमको कैरेक्टरिस्टिक मालूम होना चाहिए। तो ऐसा कोई भी मशीन जो अभी इतना पार्ट हुई है और वो बोलेगा उसको आरपीएम है, ये तो ऐसा कभी रहता है।
Okay, I think Manohar sir was on another call. Is there any particular questions that you want to ask the panel, the participants over here? Because I think the questions that have been raised over here, some of them are not present. So if there's any questions that you want to ask in particular to Gadgil sir or Murli sir, please request you to unmute yourself and take the question.
What I can suggest, see, there are many questions on the connections basically, and different type of connections, and any guideline available for that. So I think we can compile that on your end, and Gadgil sir also will ask him, and then
Absolutely.
I think that will publish on the website also. So for all the references that are available, that we can do.
Fine, that works. Yes. Arnanshu sir, anything in particular that you would like to ask?
Nothing as such, Manu. Thanks.
Okay. Shailesh sir? She had a question.
Hello.
Yeah, Shailesh sir, please.
Yeah, actually, I had one question regarding this open web girder bridges. I just wanted to ask whether the connection between this top bracing and main members, which we provide in bridges, should they be designed to transfer moment or only axial forces? Because recently we had a problem with that because some people were saying that it should be designed to carry only, it should be as an hinge connection. It should be a hinge connection, not a fixed connection. So can you please clarify on that basis, the connection between bracings and main members? How should be they designed?
It should be pin connection only, sir. If it is an axial member, where is
Right.
the movement will come?
Right, because we had designed it as an axial member only, but
Yeah, absolutely.
the issue was that the party wanted it as a moment. They were arguing that it is a moment connection. So on the
No,
basis of that, so
I guess the point is different. Sorry to
No.
interrupt. If you're, it all depends on the how you're doing the connection. If you're going ahead with your welding, whether
right,
you design in your software or your hand calculation as a moment, a pin or whatever, and pure axial truss doesn't matter. By virtue of because of the weld stiffness, it will be like a variable. You will have moments over there, and eventually that will lead to crack because that moment was not there into the design consideration. You will have the connection failure. So
actually,
those are the major thing where basically the hollow sections are fails because of the joints, because in our paperboard we take it pure axial and it goes for fabrication, we do it with welding, we don't look. So the best way that you have to ensure that you go ahead, I mean irrespective of whether, I mean what kind of design you do for the weld, if you do weld there will be some stiffness which will take
right,
into account the moment at the junction. So you have to go ahead with bolting, and that to not more than 2 bolts or something like that. Otherwise you will have the stiffness which will provide I mean make the failure will occur into your members or at the joint.
Sir,
So that
actually,
is how
we
it
had
works.
provided this top bracing was connected to the main member through one gusset plate over at the top. So initially it was like that, but after some corrections, we had to provide at top as well as at bottom through gusset plate. The connection was through gusset plate, and the gap, and there was some gap between the main member and top bracing. So the point is that if we provide, if there is some gap between top member and the bracing, but it is connected with gusset plate. Should it carry moment or?
So when you idealize a stress, you see that your last terminal connection is basically your bracing member and your cord member is at the connecting at the center point. Right.
Right.
That is how we idealized. But to make the connection work or to do the fabrication, what we do a shifting of the bracing member. So that center line doesn't meet at the same point. So that small part what you left in the main cord, that's subjected to your more than, I mean, what you anticipated in your design, more than that moment and shear that comes over there because it has to transfer that axial load over there. So there, because of that, it fails because the
Basically,
central
it
lines
is.
are not meeting.
Yeah, basically
Okay,
the moment
absolutely.
developed is due to the self weight of that bracing over
Yeah.
that gusset.
Sir,
Yeah.
sir, one thing. Yeah, that is the actually how these behavior of hollow section joints are happening. But the analysis, what we are doing is a jointed or a truss member and axial. However, as directly member to member if you are connecting, it will have a stiffness increase in the joint. Because of that stiffness, the movement, it will create a forces in the in of that cross section. That is the reason in my explanations also for the fabrication needs you are putting a gap between these two basic numbers. And because of that one, the couple will form in the bottom card member. Because of that one, face bottom card face plastification may happen, or punching shear may happen, or top flange may itself fail. If you follow those guidelines, these secondary effects will be nullified. If those guidelines are not coming because of your fabrication is, then it may require to reinforce the plates with the location of the joint. Those guidelines and even clearly they have given in select guides as well as Eurocode. But however, those details are not available in IS. That is the problem. That's why, Manu, if you can share that blue book with an example of that 25-meter truss completely, member to member connection and all joint details, those who are interested, or you can share it to everyone who has attended so that whenever they require, they can go through that.
Sure, boss, sure.
Okay. Okay, sir. Thank you.
Any other questions from the participants? Shravanti had a question. Shravanti? Okay. I think we were supposed to close at 5:15, but then we've reached 5:50. But I think that's a good sign only, obviously, because people have been interested and they're wanting to be asking questions and they wanted to hold on to the sessions. So yeah, so I think I can bring it to a close. Viraj, would you like to take it from here? Viraj and Hemant,
Yeah.
sir.
Yeah, just to give you a brief about MPD pipes, we are the business development partners for Tata Structura, and we keep ready available stocks of all the sizes that Manu has previously covered in his presentation. So, with regards to any queries with regards to the availability of material, you can definitely get in touch with us. Also, I would want to take this opportunity to thank all the participants who were present for today's webinar. It wouldn't have been a success without your presence. Thanks for gracing the event. I would also like to thank ISSE Hemant Wadalkar sir, particularly for helping us to coordinate and put this webinar together. I would also want to thank Murli boss for taking out time and giving us this wonderful presentation, as well as Manohar sir. It was a brilliant knowledge sharing session, and I believe that all of us had a lot to gain from it. Lastly, and most importantly, I would like to thank the Tata Steel team, Manu, especially for helping me to put this event together and coordinating everything. So thanks everyone, and wish you all happy Dashera well in advance.
Yeah, again, on behalf of Indian Society of Structural Engineers, I must thank all the participants, the Tata Steel team, Viraj from MPD, who has supported this event wholeheartedly. And very nice presentation by our Professor Gadgil sir, Murli Krishna sir, regarding the joints and the use of all of these sections. And I think, Manu, what we can do is for connection design, as rightly said by Murli Krishna sir, you can share whatever information you have with you. Along with Gadgil sir, I will also ask him. And we'll just make a small article, and that I will try to put in our ISSE journal as well for the
Absolutely.
reference of all these, I think, design engineers, because people are much worried about the connection design all the time. That I understand. So I think let us do that. And thank you very much for your support and help. And thank you all.
Thank you. Thank you.
Thank you all. Thank you.